Fifth grade, how are you? Good to see you again. We're going to do this a little bit different. I want you to go ahead and grab your math pack from Success Center, and I want you to turn to page 74. Okay? Wow, that's terrible. Um, we're only going to work on page 74 today, so make sure that you have your page 74 out. Now that you're turned there, this is going to work differently by I want you to pause the video right now. I want you to try to solve number 1 and 2 and 3 and 4 by yourself before you turn the video back on. When you turn it back on, if you had problems with any of them or you just absolutely couldn't understand, I will be explaining them and we'll find the correct answers together. But first, try them by yourself. Now, I also want to remind you that you don't ever solve a problem before you think it through. You circle your numbers in units, underline your question, know what you're being asked, box your action words, and this is going to be important because there are going to be those kind of clues in this problem or these problems, a lot of them. Evaluate what you know, eliminate what you don't need, and then show your work. Always show your work. So right now, pause the video and get to work and then come back when you're done. All right, I hope you're done with your work. I don't have all of the final answers right here, but we are going to talk through how you find each answer. So if you haven't done this yet, go back and do it. But I'm going to go ahead and start explaining. Number 1, which equation could represent 13 less than 1/3 of some number equals 4? Now, it sounds crazy, but if we break it down and think about it a piece at a time, it'll be okay. So it says it needs to be 13 less than. If you'll notice, I put a little subtracting sign up there. I know, or I can just put it right in there with it. I know that less than means to subtract. So it is 13 less than 1/3 of some number, and it has to equal 4. All right, first thing I want to do is I want to check out my answers. Anything that doesn't equal 4 cannot be an answer. So I come here, look, this is an equals 4 right there. We're good. This could be a contender, all right? This one doesn't. This one equals 4 minus 13. We don't need that one. Our answer, our ending answer says it equals 4, and that's it. Aha, here's another one that just equals 4. This one might work. Here's one that is 4x. Close, but not just a 4. So we can only choose from A and C just by eliminating the things that didn't equal 4. So let's look at this. This can be a little confusing. These two have the exact same numbers in them, but only one of them is correct. And this says 13 less than 1/3. Well, that looks like this one right here. 13, and then we have a subtracting sign, and then a 1/3. And to find 1/3 of a number, you would multiply that number by 1/3. And x would be that number, and we're multiplying by it. So both of these have that. But what you have to remember is if you're 13 less than something, that means your something is first, and then your 13 is the thing being subtracted. 13 could not come first here. To be 13 less, remember it has to be the second number in the problem. So it could be, this 1/3 times a number, which would be 1/3 of a number, less. 13 is less than that. That's what's confusing about doing subtracting problems or saying less than. You just have to remember that's the number that's being subtracted. That's what happened here. 13 is getting subtracted from this. So your final answer, okay, 13 was in the wrong spot here. Final answer is C. But if you chose A, you missed it in the best way, but now you can see why that can't be the answer. All right, let's go down to number 2. I'm going to change the color of my pen. And let's read. Last year, Sandra's father lived in Dallas for 12 weeks and 3 days for a temporary job. Which of the following equations can be used to find D, the total number of days Sandra's father lived in Dallas? I've already done my cube strategy here, but let me explain through it with you. It says we're working with weeks and days. So we're going to have to be careful with that. Weeks have 7 days each in them. So I need to make that as something that I know that I know. So 1 week, and I'm going to abbreviate week, equals 7 days. And I'm just going to put D for days. All right. So he was in Dallas for 12 weeks and 3 days. So we're going to have to plus, and is sometimes a word used for adding. So we're going to have to add the 3 days on in the end, aren't we? Which of the following equations can be used to find D, the total number of days? Well, you remember that trick that we used up here? Everything, or a final answer had to equal 4. Well, on this, the final answer has to equal D. But they all equal D. So we can't eliminate any quite yet. All right? So let's look. He spent 12 weeks. Well, 1 week equals 7 days. How could we find the days for 12 weeks? Because we need the total number of days, not the total number of weeks. How can we find the days for 12 weeks? Well, I can say if there are 12 weeks, they each have 7 days. And so that would just be a multiplying problem, wouldn't it? Whatever my answer is for those days, well, he stayed an extra 3 days up here. So at the end, I'm still going to have to add in for my 3 days. So let's look up at our problems and see how we can do. This one says 12 plus 7 divided by 3. Okay, this 3 didn't have any dividing clue words with it. That can't be it. Okay, we're not going to be dividing anything by 3. We are adding 3 days to the 12 weeks. This can't be our answer right here. Okay, well, here looks like something that we did. A 12 times 7 plus 3. Well, that looks exactly like what we've done right here. This is probably our answer. Let's go ahead and mark a little thing right there beside it. Okay, well, this is 12 minus 7. Nowhere in our problem does it say that there are 7 less things than 12, or 12 is subtracting 7, or even any clue words for subtracting. This can't be our answer. And on top of that, we're not multiplying anything by 3. We're just adding 3 days on to 12 weeks. And this one has a 12 times 7, so this should get our attention here. 12 times 7, that's going to give us how many days are in 12 weeks. But this says subtract 3. We better go back up and read our problem and see if we know what we are finding correctly. Sandra's father lived in Dallas for 12 weeks and 3 days. We're not going to subtract 3. We were thinking right, we needed to add 3 to the 12 weeks. All right, so we didn't need that one either. This is the answer. All right, let's go back up and look at number 3 now. This one was a little different. We need to find which one of these situations could be represented by the expression 3x plus 7. Well, when you have a number written by a letter, it means that you have to multiply that number by that letter x. So essentially this just means 3. And remember, we can use a dot for times. 3 times something. We don't even know what that something is, right? But after that, after we do that, 3 times that something, we're going to have to add 7 more things in. Might even say more with it. So let's go over here and look. Dominique ran 7 laps and Jill ran 3 more. That's a plus 3 then, okay? That doesn't have, it didn't say anybody did 3 times as much as anybody else, okay? 3x means the 3 is multiplied by something. This problem didn't do it, okay? Let's look at B. Bill has 7 more baseball cards. Ooh, I like that because the plus 7 that we needed in this problem, that would say 7 more maybe. Bill has 7 more cards than Navarre has. That means we would take Navarre's number, which would be X, and we would just add 7. But nowhere did it say that we were going to multiply by 3. That's not going to work, okay? That's just a plus 7 problem right there. So it would be just whatever Navarre has, Bill just adds 7 more to find his. We didn't multiply anything in that one. Let's look at this. Cheyenne has 7 fewer video games than Peyton has. Fewer would be an indicator of subtracting. Nowhere in our problem are we subtracting. Automatically not it. Well, I sure hope it's this next one. So let's look and see what it says. Jenna earned $7 more. It's looking good. We need more, 7 more, okay, than 3 times as much as Mark earned. So Mark, we don't know how much he is, but he's the X. Okay, she earned 3 times as much as him, plus 7 more dollars. So this is the one that we're looking at. Hope you understood. That one's kind of a tricky one. I hope you understood how I took you through that one. Now let's look at number 4. I'll change my pen color again. Number 4. During a campus cleanup day, 34 students each collected the same number of plastic bags. Their teacher added 16 more plastic bags to their collection. Which expression represents the total number of plastic bags collected? Well, let's go back up here and look. I haven't finished my cube strategy on here, but I wanted you to see part of what I've done anyway. 34 students each. That means each and every one of those 32 students collected the same thing. Okay, so it looks like down here we have the letter B. They didn't tell us anything about the letter B in our problem, but since every single answer down at the bottom has a letter B, let's go ahead and say that B logically is going to be bags or plastic bags. So B is going to be our bags that are collected. Each and every one of those students each collected the same number. Each is an indicator, especially if it's up in the problem and not in the question, it's an indicator that we're multiplying because everybody has the exact same thing. So it would be, you know, B, 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 B. So if our bags were B, everybody has B bags, right? And the teacher has added, they even gave us that word right there, added 16. So I know automatically I'm going to need a plus 16. So if each and every student collected the same number of bags, that means we have to have 34 times B. But another way to write that, okay, remember you're a 5th grader, is that if you write a number before a letter, that means, oh, I missed up right there. I needed to put a 34 there. So you put a number before a letter, That means that number is multiplied by whatever that letter equals. So 34 times B. It's the exact same thing as I said right here. But we have 34 students, each collect the same number of bags, and then the teacher puts 16 more in. Which one of these does that? Now, this one right here says 50 times B. We don't even have the number 50 in the problem. Now, if you add 34 plus 16, that equals 50, but that's not what this problem told us to do. It told us to add 16. This is definitely not it. Okay. This right here, B plus 16. That is looking so good because we have our 16, or adding 16. We have the B that equals bags, but that is for one student. So if you have a letter that doesn't have a number in front of it, it means it's just one. We didn't have just one student collecting bags. We had 34 students. So, this is looking good right here. 34B, which means 34 times B plus 16. This is looking, let me mark that one out up here. This is looking like it's the one that we need. On this one right here, this is B divided by 34, or B over 34. Anytime you see a fraction, that's a dividing problem. Are we ever dividing the bags between 34 students? No, this means bags divided by students. Nope, each student collected bags, but they weren't divided up among the students. Each student did that. So that one's out too. So our final answer would be 34 times B plus 16. So going back and reviewing, these are problems where if you look carefully within the problem, they told you whether you had to add or subtract or multiply. We didn't have a dividing in here, but that could have happened too at some point. But anyway, I hope you learned something from this page today. If you missed some, that's fine. You saw how to get the right answer this time. The next time we meet, which will be next week, in just one video next week, we're going to be doing another page very similar to this. So hopefully you learned something, and I'll talk to you next week, and have a good rest of your week. Bye-bye.